Hello, my name is Madeline Stanton, and today I will be guiding you through an example problem on proof by induction using weak induction. So our problem is to prove that 9 to the n minus 1 is divisible by 8 for all n are greater than 0. In completing this problem, there are going to be 3 basic steps, which I'm going to walk you through. So our first step is going to be proving our base case. So since the problem dictates that 9 to the n minus 1 is divisible by 8 for all n are greater than 0, our base case is going to be when n equals 1. So all we're going to do is substitute 1 in for our n. So we're going to have 9 to the 1 minus 1 this equals 9 minus 1, which equals 8. Now we have to test that it's divisible by 8. So we're going to have 8 divided by 8 is obviously equal to 1, and our statement checks out. So this just means that the statement is true for its first term, n equals 1. Our second step is our inductive hypothesis. So there's several components to our inductive hypothesis. First, we're going to set n equal to k. Next, we're going to assume that p of k is true. So this would mean 9 to the k minus 1 is divisible by 8 for all k are greater than 0. Now what we're going to do is set this equation equal to 8m, where m represents some integer. The reason we do this is that if m is an integer and you're multiplying it by 8, whatever this result is, it's always going to be divisible by 8. Lastly, we're just going to want to isolate our 9k by adding 1 to each side. So we're going to have 9 to the k is equal to 8m plus 1. Now that we have our inductive hypothesis, we're going to move on to our third and final step, which is our inductive step. In order to prove our inductive step, we're going to replace n with k plus 1. So our expression is now 9 to the k plus 1 minus 1. And our goal for this is to show that this expression here is equal to 8l, where L represents some integer. So now, how do we do this? We're going to take our expression here, 9 to the k plus 1 minus 1, and the first step we're going to do is just expand it using basic algebra. So all we're going to have is 9 to the k times 9 to the 1 minus 1. And that's just some basic algebra. Now for our next step, we're going to want to refer back to our inductive hypothesis, where we said 9 to the k is equal to 8m plus 1. Now here, we have a 9 to the k. So what we're just going to do is substitute that in. 9 times 8m plus 1 minus 1. We're just going to distribute this 9, 72m plus 9 minus 1. This is obviously equal to 72m plus 8. Now referring back to our goal, we want to show this, 9 to the k plus 1 minus 1 equals 8l. In order to do that, we must factor an 8 out of this integer here. So we have 9 to the k plus 1 minus 1 is equal to 8 times 9m plus 1, right here. Now that we have this, we're going to let 9m plus 1 equal some integer L. If we let this equal some integer L, we're going to have 9 to the k plus 1 minus 1 equals 8L, which means this expression here is divisible by 8. In addition, it's going to mean that the original statement, 9 to the n minus 1, is also divisible by 8, meaning we've solved our proof using weak induction.